So, good. Well, for me, it's nighttime, but I don't know when you'll be seeing this. I thought I could record the lecture as I'm unable to make it to the actual lecture time. So maybe this is a reasonable alternative, given that I can't make it to Eindhoven for me tomorrow. So, final time you'll be hearing from me during this course, as next week during your final presentations, I also won't be there. I have a test that needs to be made in Amsterdam, as I'm still also a student there. I wish you all the very best of luck with that final presentation and also with the final report. Any of the groups that still need feedback from me, please just shoot me an email. We can even plan a time to have a face-to-face meeting about it. That's all very possible. As for what I wanted to talk about during this tutorial, well, I think Bert in his lecture talked about a couple of concepts. I want to sort of show those concepts in the context of, specifically in this case, the Netherlands. The Netherlands has a very interesting, I think, way of going about infrastructure, going about big planning projects, going about using the social cost benefit analysis in those planning projects. So I thought it would be a good idea to sort of sketch, at least with broad strokes, how that's supposed to work in the Netherlands. So as I was thinking about what I wanted to do during this tutorial, I realized that we put this sort of front and central in this course, and that's not necessarily a bad thing. This is the net present value formula. You should be able to dream this at this point. It's definitely going to come up on the exam, I can tell you that. And we wondered about where this fits in the social cost benefit analysis. It's important. Also, it's sort of consequences for analysis on investment projects. And we had a bunch of questions surrounding this, right? So it's central to the course, but it's not at the size that first picture showed. We also need to know why we are using social cost benefit analysis. So we talked about this contingency of the tool fitting the job, also how we might go about fixing our problems, so about alternatives, who are important in those alternatives, who are the stakeholders, how this might impact stakeholders, so how the investment might impact stakeholders, how much this is worth to the society in euros, how sensitive the different parts of the projects are to changing in euro terms, so the investment changes or the discount rate changes or the inflation rate changes, also very important. And finally, coming to a recommendation. So knowing this and knowing the 10-step guide, over the last few weeks, I think we've sketched a way of how to do social cost benefit analysis, but we haven't really shown how this works in the Netherlands. Because I think the context of the Netherlands is sort of important, and it's also important to understand how we got here, and how the landscape changing around the place where the social cost benefit analysis is most used influences the tool and its uses. So what do I mean by that? Well, I have two pictures of Eindhoven here. I thought Eindhoven would be a fun example because, of course, the university is there. One, I think, is from about 1925, and the bottom picture is from around the 1960s or the 1970s. And you can see these are at the same scale, by the way. So you can see how much Eindhoven has grown and how much less space there is. So this changing context around the infrastructure, around the place where we get to do big investment projects, well, it's reasonable to then assume that also has an effect on how we evaluate those projects. So for example, you can see there used to be another railway line that went through Eindhoven towards Valkenswaard, which has since been torn down because of changes in the landscape and in the context of infrastructure projects. We also already talked about why the social cost benefit analysis is useful generally. We talked about that. Normally in more authoritarian countries such as Saudi Arabia and Russia, planning comes down to individual choice. The leaders of the country want to use the wealth of the nation to do a specific project, and they say so it happens. And we discussed that the social cost benefit analysis is good for accountability and transparency, and justifying expenditure, because taking money from your citizens in the form of taxation, which is how we do it, we have differing opinions maybe on whether that's just or not. I think it's generally a good idea. But we want to make sure we justify that expenditure to the people whose money we spend. We talked about the benefits this brings to policymakers, to analysts, to the public. This is all in general terms. But what I wanted to do over the coming 40 minutes is to talk about how this works in the Netherlands specifically. And there also we talked a little bit about initial research of private consulting firms and the peer review and second opinion of public organizations, and that looked very differently. So the market often provides sort of this nice report printed in color, and then Centraal Planbureau has a more sober, more simplified way of getting information to the public at large. And we talked about how the second opinion sometimes leads to consideration, and that this is a two-step process, but we haven't really talked about where this process fits. So I wanted to tell a story to sort of show how far we've come as a country in determining how to go about planning infrastructure. And I wanted to do that based on the development of a specific mode of transportation. So I'm going to focus on the Dutch railway network, which was sort of developed from the early 19th century to today. And there's really three phases of development this railway system went through, ending with the modern social cost benefit analysis. So it might be a bit of a hike, but we'll get to it in the end. So first of all, I thought it was a good idea to sort of step back and to understand how networks work and how sort of planning works as a general rule across the world. So if you ask a planner to sort of conceptualize the world around them, they will maybe point to this model. This is a model of planning that is taught to planners in university, so I thought it would be a good idea to repeat it here. It sort of states that the world around us can be sort of divided up into three different layers. First of all, we have the underground layer, so sort of geological features, whether there's mountains or natural forming rivers, that sort of thing, or natural resources might also be part of the underground domain. And then above that, we build networks as a society. So you can see different networks there. There's a railway line, and there's a highway, and there's other kinds of roads, and there's a canal, and there's electricity infrastructure, but there's many more networks than this. Some are even invisible, so you think of telecommunications or wireless telecommunications networks. Satellite television, for example, is a network, global network, which we can't see because the satellites are 34,000 kilometers away from us in geostationary orbit, and they beam their signals invisibly to our antennas. So sometimes these networks are very visible, sometimes they are not. It's important to know that can both be the case. And then above that, we build sort of the visible part of our society, or the part that we're most conscious of, which is the occupation layer, which is where our houses are, which is where our farms are, how we sort of divide up that space to live in as well as we can possibly manage. So this ground layer is interesting because it is not influenced by us as humans, or at least very, very little. And it changes very slowly. It might change over thousands of years. So you can think of things like continental drift. So I think Australia is moving towards China at 2 centimeters per year. So that's important in the long run. And it's important to know the consequences of that, because continental drift causes things like earthquakes and tsunamis, which are important to planning decisions. But we can't really do anything about it. It's a fact of life. We have to live with it the way it is. So it can't be influenced. Then the network layer is sort of characterized by this idea of investment, a very large investment, and many different kinds. I already sketched some different kinds of networks that we have. And this is also long-term thinking, but it's more proactive than the ground layer. It's not reactive to, but it's proactive of what can we do. And it's thinking over many decades. And then finally, we have the occupation layer, which is what we build on the previous layers, right? So we We use roads in our cars, and we build houses in certain places, and we have sports fields, and we have recreational areas. So what layer are we most concerned with? Well, most of the time as planners, we talk about this network layer, really the network and the occupation layer. But for the social cost benefit analysis, many of you have really focused on this network layer, and that makes sense because that's where a lot of investment is, and a lot of this idea of calculating benefits over time is very very connected to this idea of networks and their development. So this is often where we focus. Now, networks kind of develop in an interesting way. I'm sure you've heard of the S-curve, and I'll show an example of this. That networks develop in four sort of distinct phases. You have the start, and then you have takeoff, and then you have maturity, and then finally you have a phase called reconsideration. So things that we can think of like in the start of their development or nearing takeoff is things like 5G, right? Very fast mobile wireless internet. It's sort of in the start or takeoff phase of its network development. Things that are mature might be things like the highway system. The highway system was built between, I'll show a picture of this, sort of the 60s and 70s and maybe the early 80s was sort of the peak of Dutch highway building. But since then, not many kilometers of highway have been added. So you could say this network is now mature. Same goes for the railway system, although I think the railway system is in the reconsideration bucket, along with things like the waterway system, which is something we're going to talk about later on. So what network could this be, right? So we see that there was a start to this network, and that there's a clear takeoff, and then we see sort of around the 1970s, 1980s, we see it reaching maturity, and then it being sort of really mature by the time we get to sort of 2005 timeframe. But already growth really slowing down at the start of the 1980s. So what network might this be, do you think? Give you a couple of seconds to think about it. This is the Dutch highway system. So in 1937, there was almost no highways in the Netherlands. Then it really took off in the 1960s, sort of this democratization of the private car. During the 70s, there were many politicians sort of having this ideal in the Netherlands of every worker having his own car. It was a big part of the PvdA, so the Partij voor de Arbeid. The Labour Party's policy was trying to get a car to everyone, trying to make a car an accessible thing to everyone, and that sort of shows in how the network developed to respond to this call for democratization of the car. And then we see sort of slowing it down in the 1980s as a result of the oil crises and fuel prices going up. But still some widening, some extension of the network happening here and there until we get to 2022. So mature network might be going into reconsideration at some point in the semi-near future. Showing this a different way is this is the amount of kilometers that were added to the network every year. So you can see that in the beginning it was really focused on creating more kilometers of road and kilometers of sort of lanes. So also highways going from the standard being a 2-lane highway to being a 3-lane highway is clearly sort of visible here. But also from the 1970s forward, you see that widening roads becomes a larger share of the activity on the Dutch road network. So you see how the network developing over time sort of changes how it develops as well. So something I want to talk about that Bert already talked about in the last hour is depreciation and how it sort of gets in the way of our development. And this is really sort of where our story starts. And I sort of want to take you back to the early 19th century and sort of the Industrial Revolution. And I want to ask you, what do you think the main mode of transport was in the Netherlands at that time, sort of talking 1810, 1815. So the answer to that is walking. So many people walked most places. The bicycle hadn't been invented. The horse existed, but horses were quite expensive, and so for upper class people, coaches. So pulling something with a horse was also a thing, but still, you have the horse. It's very expensive. And one other way that most goods were transported was using what they call the trekschuit. So we had a system of canals in the Netherlands with paths running alongside them, and then you had a horse that could pull a boat. And this really was a very efficient, very slow, but very efficient way of moving a lot of goods from town to town. Because the boat could be loaded very heavily and it could be moved by a single horse because there's very little friction in the water if you move slowly enough. Which meant, and this way of transport being really popular and really well suited to the Dutch geography, meant that we developed a canal system that was very advanced for the time it was being built in. So there is canals that go back to sort of the 15th century in the Netherlands that were dug by hand as infrastructure. And it really meant that the Dutch Delta had among the best connected canal system in the world. But the speed of that movement really meant that people didn't really go anywhere. So I know I'm not here with you guys right now, but when I teach, a normal Tuesday for me is covering, what is it, from Utrecht to Eindhoven is about something like 100 kilometers. Then I go from Eindhoven to Amsterdam, which is 150. So we're at 250. And then I go home, which is another 50. So we're at 300 kilometers. 300 kilometers is not a very special day. It's very, very feasible to do 300 kilometers in a day for us as a modern society. Even without a car, it's like that's using public transport. If you asked someone to do 300 kilometers in a day in the 19th century, they wouldn't be able to conceive of being able to cover those distances in a day. There was nothing in the world that could cover 300 kilometers in a day. No animal, no way of transportation could do that. So it's real privilege to sort of think about how free we are to go where we want to go and to go where we can go in our modern society when you think back to a canal system and sort of walking being this dominant mode of transportation. So the canal system, this is what that looked like. Much of it still exists today, but to a significantly lesser extent. And I'll sort of talk you through this. Everything that's dark blue still exists and is like a large canal. And is also used still quite a lot. So especially the route from Amsterdam, which is in the bottom left, to going up to Stavoren and onto the canal network in Friesland, going to Groningen. That is used a lot for bulk ships, but also for ships carrying containers. And then you see everything that's in lighter blue is now a non-navigable canal. So that used to be part of the Dutch canal network, but has been sort of closed and decommissioned since that time. Then there's also a lot of canals that have disappeared. If we look into Oost-Groningen and northeast of Drenthe, you see a lot of canals that used to exist but have been are now no longer visible. And there's also some canals that were never built in the first place. So you can see this was a really extensive network of logistics that already existed. We're talking sort of 1700s, 1800s, and that has been seen expansion really until the 19th century and even into the 20th century, and some expansion this century as well, but quite limited. So going back to our story, going back to the story of the railways, this canal system that was really good and that worked really well sort of meant that the Dutch were extremely late in developing its railway system. And that's something interesting to think about. So say that you have something, right, a process or a tool that works very well, and someone comes along and says, hey, I've got this new idea, this new thing, it's an investment, and it does the same job that your tool does, but it does it much better. But the thing is, you've already invested a lot of time and a lot of money into optimizing the tool you have already at your disposal. Which means you'll probably be pretty reluctant to adopt the new process or the new part or the new tool. So, funnily enough, because the Belgians had a less well-developed logistics system based on canals, they beat the Netherlands to having railways. So the the Belgian railway network is actually much more dense and older in many places than the Dutch railway system. By the 1840s, the Belgians had built much more rail than the Netherlands had. And then you can see in 1870 where that had got them to in terms of a sort of a country-spanning network. It's pretty impressive when you look at that. For example, in 1860, the Dutch railway network looked like this. So you see what's called the IJzeren Rijn, or the Iron Rhine River running through Limburg. 2 lines running into the Netherlands from Belgium, and you have a line running from Utrecht to the east, and what we call the old line, which is Amsterdam, Haarlem, sort of Leiden to Rotterdam. It's even called the Oude Lijn because it was one of the earlier railways in the Netherlands. So then in 1860, the Netherlands gets the Railway Act, which creates much of the network that we understand now in 20 years. So after 1860, the Dutch really sort of wake up to this idea, okay, this new technology is something we should adopt and we should get on this. And it actually, in 2 decades, which is pretty quick pace, we get a countrywide railway network. So you can see here that we go from takeoff to reaching maturity quite quickly, actually. So this, I would say, is still in the takeoff phase, 1860. But then if we look at like the 1880s and the 1890s, it's pretty advanced. It's pretty advanced. Much of the railway system, and even a little bit more in some places of the railway system that we have now, exists by that time. So I already sort of alluded to the idea that if you replace something that you have with a new technology is hard to do. Because there's investment tied up in the old way, so to say. And this, we can calculate this by using something like capital destruction, is what it's called, kapitaalvernietiging, literally in Dutch, which sounds pretty severe. And I'll try to explain what that means. It has to do with depreciation, which Bert talked about in the beginning. So if we replace something, we write down the legacy asset, so what we used to have, to 0. So let's say we spend 50,000 euros on a car. It's expensive. Let's say next year a new technology comes along which renders your car obsolete. Like totally makes it look useless, makes it look absolutely useless. So let's say teleportation is invented, free teleportation is invented next year. So then your car is literally useless, right? It serves no purpose anymore. Because you could do everything in your life more efficiently in a different way for free. So it's a thought experiment. So your car would immediately be worthless. And this sort of makes you hesitant to invest in the replacement because you've just spent money on having a car, quite a lot of money. And now you're saying it's useless? Well, there's going to be resistance to that idea, which is exactly what happened as I described in the Dutch case where we had canals and then we had the railway come along. So it's important to remember that when you sort of really look at system change or system replacement, that there's a lot of what we call sunk capital, sort of this money that we can't get back, which is invested in the old way, which you would have to, as I say, write down to 0 and sort of realize a loss on if you want to move to the new system. This is important to remember. So as I say, canals were replaced by railways eventually, once steam engines got practical. So this is actually an interesting story. Early attempts for railways were dependent on a lot of different systems. Some people actually also try to do something called an atmospheric railway. If you want to, if you're really interested in sort of, I guess, pneumatic technology, you should Google atmospheric railway. It's fascinating technology. But really by what we call what was called the Rainhill trials of 1829, we get the first practical application of steam engines on rails. So this is what that looks like. It was a father and son team both called Stevenson, who invented the first practical railway locomotive. There was a prize to create a practical steam locomotive, because the merchants that were operating in the area around Birmingham wanted a faster way to get their goods and passengers around than using the canals. So it was specifically to try to replace the canals as a mode of transportation. And you can see why you might want an advantage, or might want an alternative to canals, because of course you can be faster, you're less dependent on other factors, so you can be more punctual. Railways were a lot cheaper to produce than, or cheaper to build than canals. There's less of a barrier, so for every canal you need a bunch of bridges. Railways, not anymore, but then you could build railway crossings with very little effort. It was very simple to sort of say, well, you just walk across and you'll be fine. They had a smaller footprint and they could have similar carrying capacity to ships at the time. So there were a lot of reasons for this new technology to be adopted rather quickly. This is what that steam engine looks like today. It's fairly small. It was called the Rocket, and it went 48 kilometers an hour, which was the fastest moving object in the world at that time, which I always find sort of funny to think about. The fastest moving object in the world would be 48 kilometers an hour. But we talked about this resistance change. So where does that happen in the railway canal story? So you get people saying, but we invested so much in canals and you are now saying they're going to be worthless. Shouldn't we at least try to get value out of what we invested in before? And so it leads you to taking into account this idea of capital destruction into your calculations for what the real costs of adopting the new technology are. So let's say you have invested 100 million in a canal, and through linear depreciation, which Bert talked about in the previous hour, it should still be worth 80 million. But now the technology of canals is eclipsed by something new. Well, the canal is going to be valueless after you adopt the new technology. So 80 million is the book value of the canal. That should be included in your costs, because you invested money in a thing that is now going to be worthless. And you should take that into account when calculating cost and benefits for your new technology. When talking about this resistance, it is important to think that at this point in the Netherlands, there was no formal way of evaluating whether something should be built or not. So there was no way of critically and objectively evaluating cost and benefits. There was no standard practice. There was much less centralized government in those times, mainly due to the fact that word traveled slowly in those days. And even until sort of the 1950s and 60s, a very large combination of qualitative and quantitative methods were used to eventually inform political decisions on whether a piece of infrastructure would be built or not. So you see that this sort of irrational, in some way, resistance, but also rational and irrational resistance to change could really hold a country back in its development. Sort of the numbers say you should, but because you have just done this investment in something else, you're like, oh, should I now? This is going to be worthless, and should we then do it? You see that there's sort of really a space for standard practice to evolve, to help depoliticize these decisions. So, as you can see, eventually the railway system in the Netherlands really got built. This is the system as we know it today. Everything that's blue is electrified, everything that's red is electrified in a different way, don't get me started, and everything that's black is run using diesel trains. But when you compare it to something like Belgium, you can see that their network is actually more dense. So you can see again that Belgium had an advantage in creating the railways due to their disadvantage in waterway engineering, and therefore they have a better railway system even to this day. The Dutch system is very good, and it outperforms the Belgian railway system in a number of different ways. But in pure density, the Belgian railway system is actually really good. With regards to electrification, it's also a bit better. So then for the railway, we sort of have this maturity of the network, as I sort of talked about. The network is then modified in a number of different ways. So we see large scale electrification happening, even going on during the Second World War. So steam trains being replaced by electric trains over time. Sort of final connections are made, but then roads really start to gain in popularity, and that even happened during the pre-war era, sort of this interbellum period between the First World War and the Second World War. And the Netherlands actually gets its first highway in 1927, which is fairly early on. I think only Germany and Italy were before the Netherlands in their first highway efforts. So Germany is very well known for having the Autobahn as sort of the grandfather of European highway systems. It was also what inspired the United States' interstate highway system. But the Italians actually were also early innovators of highways with their autostrada concept. And this highway system developing, and also the further development of especially heavy diesel based vehicles that travel on highways like trucks and buses, leads to reconsideration of the railways in some way. So we get the closing of lines, we get industrial connections being cut to factories because they switch their logistic operations to road, and we see freight traffic really declining towards the 1970s, the 1980s, and through to the 1990s, leading to eventually the National Railway Company of the Netherlands selling its logistics daughter company, NS Cargo, to Deutsche Bahn. So you see this real reconsideration of what the network not only has to be, but also what the network means. So critics of the way the Dutch railway system is being managed at the moment say it's really more of a Dutch tramway system, because it doesn't really do the proper work of transporting things like coal or heavy aggregate trains or whatever. It doesn't do that anymore, and they sort of see this as this well, the neutral term would be reconsideration, but they really see it as sort of this decline of the importance of the Dutch railway system. So that's what happens during reconsideration. But then, funnily enough, in the midst of all this, in this whole story, it's really a railway project that sparks the idea for a standardized social cost benefit analysis. The Netherlands is sort of unique in Europe, as it still does a lot of logistics across the water. If you actually look at the ton-kilometer performance of the Dutch logistics network, one, it's very good, and two, it is very heavily focused on road logistics, which we can all very understand, but also waterway logistics. So much so that 40% of all the ton kilometers that are traveled in the Netherlands, so if a ton of cargo moves a kilometer, that's a ton kilometer. So it's just the amount of cargo times the distance it moves. 40% of all the ton kilometers in the Netherlands are actually transported by waterways. And that's, I think, 5 times the nearest competitor in the European Union. So the Netherlands really is this road and waterway country. But funnily enough, then this idea comes to build a new railway line that is especially made for freight. Weirdly enough, during this time of what we see as sort of reconsideration and decline of freight on the Dutch railway network, trucks become better and better. The waterways are still improved here and there. And then someone comes up with this idea for what we call the Betuwe route. And really the genesis for this idea is the Betuwe line, which we can see from Dordrecht, which is on the left of the picture, running to Geldermalsen, the blue line running to Geldermalsen, and then continuing as a black line towards Arnhem-Nijmegen area. That reaches its full capacity. So there seems to be growth, at least on this part of the Dutch railway system, for freight traffic, especially because the Ruhr area in Germany, where this railway eventually leads to. And there's this idea to create a new connection on this to really increase the capacity here. which would eventually be known as the Betuwe-route, which maybe some of you have seen if you take the highway from, if you take the highway from Geldermalsen down to sort of Nijmegen, Arnhem area, which I think is called the A15. It runs along the A15 for a good portion. Now, this project really sort of got out of hand. So much so that a parliamentary commission, the Commissie Duivenstein, had to be had a brief to do a real investigation into the way that the decisions around this railway line were made. And their conclusion was that the necessity of the railway line was not properly explained, which is a pretty heavy indictment of an infrastructure project. When you really think about it, what is infrastructure meant to be? Well, maybe necessity or necessary. If infrastructure is not necessary, then what function or what purpose is it serving, right? So that's a pretty bold statement, especially for politicians who try to sort of paper over mistakes that they made. The line also suffered from very bad cost discipline. So it was allocated a certain amount of funds, and then it ended up costing far more than that. There were bottlenecks in Germany that to this day prevent full exploitation of the line. So the line is capped not because of its capacity, but the capacity of the railway line it connects to in Germany, which is a real problem. It can't handle any more trains, not because it can't, but the thing it's connected to can't. Eventually, there's also no terminal built in the east of the Netherlands, so there's very little domestic use of this railway line. Everything that goes on to, or most of the very high proportion of what goes on to the Betuwe-route all goes to Germany. None of it is domestic use. None of it goes from a place in the Netherlands to another place in the Netherlands. So too long didn't read explanation of all this is that there is a call for standardization. Can't we think of a way to evaluate the necessity of certain infrastructure projects so that we can compare it and sort of at least explain the necessity properly, as the Commissie Duivenstein put it. So that eventually leads to what we call the Meert procedure. This is the way in which infrastructure is built in the Netherlands. Now, there's people that like this, there's people that don't like it, that think it's bureaucratic and slow and unresponsive. But it is the way it's done. It was really formalized between 2006 and 2009, eventually became law in 2009. So if you want to build an infrastructure project in the Netherlands, this is how you do it. And as many of you will end up working in something like consultancy or maybe with infrastructure, I think it is important to know how this works. So, it requires a social cost benefit analysis as part of the procedure. So it's really important to understand that the social cost benefit analysis really is a part of the Meert. It has to be included at some point. So that's also why we teach it. So where does the Meert start? Well, it starts with an idea. And sort of anyone can come up with an idea. So what I've put here is a concept that has existed for many years of putting Schiphol into the sea, right? So we see Haarlem, we see the old location of Schiphol near Hoofddorp in Amsterdam. And we see this idea of why don't we put it in the middle of the sea where no one is bothered by it. And this has advantages. It also would cost a lot of money. It would also cost a lot of more money over time. But this idea came from somewhere. It doesn't really matter. It might come from a politician. It might come from an expert. It might come from a media. It might come from a professor at a university somewhere. It might come from local government or really departments from industries of the government. Ideas can come from anywhere. Anyone can have an idea and anyone can promote an idea. And it's really in this promotion stage where you start making the connection to the Meert procedure. So once you have an idea, you would probably go to a politician to say, hey, could you put this on the agenda, whatever that means. So put it on the agenda means that it goes into the discussion of what needs to happen with the Netherlands for it to remain competitive and prosperous, basically. Now, then step 2 comes, which is called Meert onderzoek. reports about the project can be written before a proper meertonderzoek or meert research project is done. But normally the first formal way of thinking about what this project really would mean for the area that is affected by it comes with the meertonderzoek. And basically what the meertonderzoek tries to answer is, should this project be included in the meert procedure? So the meert procedure really is this document with a list of infrastructure projects that are happening in the Netherlands. And whether they'll be completed or not, that's a whole different story. But things that we are currently considering building or actively pursuing. So this step really is about determining, is it a good idea? So we come up with sort of a global cost estimate, not very precise, but precise enough. And we come up with ideas for impacts it might have on the economy, society, welfare, space, and nature. And it's important to realize that in this stage of the research, we have a free choice of assessment method. So, for the last 6 months, I was involved in what we call the meertonderzoek of the Neder-Saxe-lijn. And the Neder-Saxe-lijn is this idea of a railway line between Groningen and sort of the east part of the country, which is Almelo, Hengelo, Enschede, which would involve upgrading railway lines that already exist and also building a new part of a railway line between Stadskanaal and Emmen. And what we try to do is sort of map out the consequences of that development that it would have on the economy, society, welfare, space, and nature. So if you want to read that, the report has now been published. It's been sent to the different political chambers in the Netherlands so it can be voted upon. And here, again, as I said, you have a free choice of determining in what way you should analyze the project. So here, social cost benefit analysis is maybe useful, but it's not compulsory. It's not necessary. That comes in a later stage. But then if meertonderzoek is positive, broadly positive, and the politicians decide to allocate some more funding, the project goes into this meert document, goes on the list of things that might happen, might actually be built. So then we are in the procedure. We've now made it into this document, onto the list. And then we get to what we call the meertverkenning, which sort of is, I always found pretty confusing because the verkenning, what would that be in English? It's sort of this exploration. This research part sounds like a more advanced stage, but the research comes before the exploration, which I find slightly annoying when I have to think about the order of things. But we are now into this meert document. And here a more expensive research project is basically commissioned. So here we do a social cost benefit analysis. And the social cost benefit analysis now is still mandatory for going into meertverkenning. One other thing that is mandatory is that there has to be what they call perspective on 75% of the project cost being financed in some way. So you need support from local governments, you need support from the national government, you need funds basically to be lined up to go into this meert document. Now, in terms of the social cost benefit analysis, I already mentioned this. There's 192 pages on what we call the leidraad for the social cost benefit analysis. And this has to be followed. It's standard procedure. Now, the conclusion that comes from the meertverkenning is not final. Or the conclusion that comes from the social cost benefit analysis is not final. Actually, not at all. I think I previously showed you some data of projects that went ahead even though their social cost benefit analysis outcome, net present value, was negative. So it's not a death nail. The social cost benefit analysis is an important part of this consideration, but it's not a death nail for your project if it scores badly, or it can still not go ahead if it scores particularly well, because there might be other considerations that are important to deciding whether the project goes ahead or not. And so projects can be given the benefit of the doubt. In many cases, they are. The Betuwe route, for example, given the benefit of the doubt. The Noord-Zuid line in Amsterdam was given the benefit of the doubt. There's bridges, the A73 bridges were given the benefit of the doubt, so to say, because they didn't score very well on the social cost benefit analysis. Right, then we go into what we call the meertplanfase uitwerking. And here's where we really nail down what the project really is going to look like. And it's a closer look at the actual specification of the project and specific alternatives, talking about speed, capacity, questions of market participation. How are we going to actually do this? So here we're steaming towards sort of starting construction, right? So it means that a lot of decisions have already been taken towards actually constructing the infrastructure that is at hand here, and that we are ready to go for it, basically. And that ends with what we call tracébesluit. So a tracé really talks about the space the project is going to need for, sort of the physical space the project is going to need to be built. That's what tracé stands for. It's a final route choice. This is really important for things like land acquisition and nature loss compensation. And this is really where we get a signature from both the Secretary of State for Transportation Infrastructure and the Minister for Transportation. And they sort of sign off on this final plan, and that means the project can be basically built. And then it gets put out into the market for private companies most of the time to bid on the construction. So if you have a construction company and the Dutch government says, we want you to build, I don't know, like a series of locks for a canal, then you could bid on that and say, oh, I will do it for this amount. And then you'll be competing with other firms in the market who might be offering lower prices or different ways of constructing this. And then there's a competitive bidding process that determines how the project is finally going to be built. And then we get to project realization, which is the really expensive part. So people say this way of thinking is really slow and expensive. And that's right. I think I can talk about sort of global cost estimates for every step in this. So the meertonderzoek is, depending on the size of the project, maybe a couple million euros. Then the meertverkenning becomes sort of tens of millions of euros. And costs a bit more time. So the meertonderzoek might be a year. The meertverkenning might be 2 or 3 years. And then again, planstudie might be 2 or 3 years. And then, so you can get up to sort of a decade, 15 years before we get even towards a project start. But the counter argument to that is that we want to be careful again about justifying, making sure our expenditure is well justified. So in some cases, we're talking about tens of billions of euros being spent on projects. So, we want it to be relatively well founded. So catching a mistake early while we're still spending only millions of euros is much better than rushing towards construction and sort of going halfway through and finding out that we made a mistake, but we've already spent half our construction budget, so we're into this for 5 billion euros. So advocates for this procedure have really said, yeah, well, it may be long, but it at least it makes sure we don't make a very silly mistake, or at least it lowers the chances of us making a silly mistake and wasting taxpayer money. It really considers at every step of the process that, well, is this still a good idea? Should we do it? In what way should it be done? What are the costs? What are the benefits? And as I said again, in the middle of this project is really important, that social cost benefit analysis, which hopefully after this course you'll be able to do perfectly without making any mistakes and making sure that our taxpayer money is spent well. So that's why I thought this would be important. Some of you, many of you, maybe one of you will end up at a consultancy somewhere, and I think it's important to know these things. Maybe also for people that are here internationally. The Dutch context is very interesting. The Dutch government or sort of countries learn from each other in general, so Dutch people learn from how things are done elsewhere. other people learn from sort of the Dutch way of doing things. So you might take this to back to another country and sort of be able to explain, oh, these Dutch people, they do it very weirdly. I'll explain how, because this guy explained it to me once. So that is sort of what I was hoping to do in this past hour. Thank you very much for your attention. I've really enjoyed doing these lectures. Maybe you've noticed that I really enjoyed this. It was actually the first time I've ever given lectures for a course, but it's lived up to expectation, and you've been a very significant part of that, because I can imagine situations or classrooms in which it would be much harder to teach, and you've made it relatively easy for me. So thank you for that. Now, on some practical stuff, if you have questions either about this lecture or about Excel or other parts, if you're not part of my groups, if you are part of my groups, feel free to send me an email with a question you have also for the exam, and I'll be happy to answer. Maybe it'll take a day or two, but I'll definitely get to your question. Then I won't be there during your final presentations, but I hopefully will be there at the exam. So if you get stuck with a question on the exam, there's a chance you might get to ask me about it, and then I'll have to be very disciplined about what information I give away and what information I do not. So hopefully until then, and once again, thank you.